Alright, so this video is meant to be studied after you learned about the normal curve and the bell curve in the previous video. And this video is about using normal distribution and understanding the z-score or the standard score. Alright, so the z-score or the standard score represents the number of standard deviations a random variable x falls from the mean in a normal curve. So that's my normal curve, and the z-score represents how far it is from the mean. On the right side of the mean, z is positive 1 for one standard deviation, z is positive 2 for two standard deviations, and z is positive 3 for three standard deviations. And on the left side is negative 1 for one standard deviation, z is negative 2 for two standard deviations, and z is negative 3 for three standard deviations. So this is z. Z could be negative 1 is 1, 2, 3, 0, negative 1, negative 2, and negative 3. And those would be the z-scores. Sometimes, though, the data don't fall on the whole numbers. Sometimes the data points fall somewhere right here, like 1.5. And z will be 1.5. And this is how we'll find the z-score if the data does not fall on one of these numbers. Or if it does. The z-score is basically the data point take away the mean divided by standard deviation. In symbols, it would be x take away the mean divided by standard deviation. You might see it written like this as well. X take away the sample mean divided by the standard deviation. Or sample standard deviation. Sample standard deviation is written as s, lowercase s. So all those different ways of saying it. So x take away mu, which is the mean, divided by sigma, which is standard deviation. And there it is. So that's how you find the z-score. So it says, given this example, it says a data set is normally distributed with a mean of 70 and a standard deviation of 2. Find the z-score for 73. So to find that z-score, is z is going to equal to the x they gave you, take away the mean, divided by the standard deviation. So the value they gave you is 73. The mean they told you was 70. The standard deviation they said was 2. So 73 take away 70 over 2, which is 3 over 2. So it's 1.5. So the z-score for that data point is 1.5. So it's to the right of the mean because it's positive, and it's at 1.5. So that z-score will look like this. This is my mean at 0. This would be 1. This would be 2. And that z-score would be right there at 1.5. Basically, it would be all the areas shaded to the left of that number. So the picture of that 0, that z-score, would be all the areas shaded to the left of 1.5. We're going to talk about finding the area there now. So they didn't ask. I'm going to ask you, what is the area under the curve for this z-score? And this is how you find it. The area under the curve for that z-score, you basically take the standard z-score table. This is the standard normal distribution table that we find the area underneath the curve from the left and the z-score. All right, on the left side, you got negative values. So all this means you're on the left side of the mean. So a picture of this part would be, if this is the mean, all these values represents this side of the mean, the left side of the mean. Here, all these numbers are positive. All these z's are positive. So this side, this is the mean, represents this side. All these numbers on the right of the mean. But we'll start on the right, but we'll take both sides. So we'll go from this point and backwards. So it represents the number starting on this side, going backwards. All right, so anyway, so that's what z-scores are. The z-score is 1.50. 1.50. So to do that, you go to 1.5 and find the column of 0. This is 0, 0. So 1.50 is right here. That means the area is 0.93319. So the area of that curve is 0.93319. You might call that area 93.319%. All right, so all those are true. This is where the area underneath the curve is, or that's it as a percentage. And just so you know, area underneath the curve equals percentile, which also equals probability. So I'm going to ask you area underneath the curve. I'm going to ask you the percentile. I'm going to ask you the probability. All those are the same thing. Is that number you get from the z-score table. That tells you what that is. All right, let's do some more. This is my z-score table practice. It says find each. That P means probability. That means the probability that Z is less than 1.24. So I'm gonna draw a picture. It says sketch a graph each time. So here's my picture. Here's that Z at 0. Here's Z at 1. Here's Z at 2. So 1.24 is right here. So I'm gonna shade all that. That's my picture for it. And you want to find that area underneath the curve. You want to find the probability of landing in this area, or this percentile. This is how you do it. You go to the z-score table, go over to 1.2, then line up with 1.24. Here's the 0.4 part. So 1.2, go all the way over to this, and it's 0.89251. So this one is 0.89251. So that's probability. You generally like probability as a percent, as a decimal, but you will see it written as a percent too. Some people just write it that way, for whatever reason. They just like to see it as percent. So don't get confused if they write it as percent. But truth be told, it should be a decimal. But you see it either way. And how you get this percentage is you multiply that by 100. Or move the decimal space over twice. The next one says probability of Z being greater than negative 0.41. So let's draw the picture. Here's my bell curve. Here's 0. And negative 0.41 is on this side of 0. So this is Z equals negative 0.41. So let's first find this area. You want a probability of being greater than, so we're going to talk about that next. But let's first find this area here. Let's go to our z-score table, and we got to go to the negative side. And negative 0.41, this is 0, 0, that's 1. So here it is. 0.34090. This part is 0.34090. So you want to know the probability that Z is greater than that. So truth be told, you want to know the Z values on the upper half here. You want to know the Z values over here. You want to know the probability you choose a number that's someplace over there. So two ways to think about this. Let's think about this as a percent. That's 34.090%. On this whole curve, you have 100%. If this whole curve gives you 100%, and this part gives you 34%, you want to figure out what's left on this side, right? Well, you probably just take 100 and take away 34.090. You'd be right. You plug that into your calculator. 100 take away 34.090 is 65.91. So this probability is 65.81. Or 0.6591. Either way. But that's what the probability is for that one. The next one says, find the z-score, the probability that the z-score is less than negative 1.36. So I'm going to draw a picture for it. For z to be negative 1.36 is somewhere down here. because that's -1, right? So that's -1.36. So here it is. That's a z. Score of that value. That's his area. And we want to find that area. So go to the negative side and go to -1.3 and slide over to the 6th column. So there it is, 0.08691. So this area, the area, 0.08691 or 8.691%. All right. Hopefully getting the hang of it. That's the idea. That's what you do there. This one says find the probability of z being greater than 2.21. Put it over here. So the positive 2 is on the right side. So someplace over here. 2.21. I'm going to shade everything to the left of it. So for that to be my z-score, I should go 2.2 and then line up with the 1. And that gives me this, 0.98645. So this probability is 0.98645. Now it says z being greater than that. So you want the right side of it. So after you found the answer there, you go back and reconsider. I do want the right side. So I don't want this part in red because that says greater than. So I'm going to change this to decimal, 98.645%. So I'm going to take 100 and take away 98.645. So 100, take away 98.645, and it's 1.355. So 1.355. So this answer is 1.355. 1.355. Or, one second. Again, that's percent. Keep that in mind. Or as a decimal, that would be over twice. So 0.01355 as a decimal. All right, this is no different from the other ones. This is the only one that's a little bit different, so I'm going to do this one next. All right, I'm going to write this on a new sheet of paper too. This one says probability of -0.5, and z is in between that and 1.3. So if that's true, I'm going to draw the z-score for it. The left end is -0.5, so it's over here. So I want this portion. I need to find that portion. And the upper end is 1.3. So I need to find this portion as well. I'm going to make it a different shade. I get a lighter shade. So ultimately, you want a probability that z is in between those two. So you basically want to find this lighter shade right here. So you're going to first find this area, then you're going to find this area, and then subtract them. So the z-score is -0.5. So -0.50. It's here. It's 0.30854. It's 0.30854. And the z-score at 1.3 is on the positive side at 1.30. And that's 0.90320. So 0.90320. You ultimately want the difference between those two. I'm going to change them both to percentages. So this is about 30.854%. This is about 90.320%. So you want the difference between those two to get this area. So I would take 90.32, take away 30.845, and 59.475. So this space is in between those is 59.875. I think it's 875. So that probability is 59.875% probability of getting a z-score in that area, or 0.59875. All right, so that's it about z-scores and how to use a table to find z-scores. Now let's put it to use. All right, so in this problem it says, a survey indicates that people use their computers an average of 2.4 years before upgrading to a new machine. The standard deviation is 0.5 years. If a computer owner is selected at random, find the probability that he or she will use it less than 2 years before upgrading. Assume this variable is normally distributed. That means on a normal curve. So let's first draw the normal curve. It said the average is 2.4 years. And then they said the standard deviation is 0.5 years. So it's going to be 2.9. And that's going to be 3.4, 3.9. So that's 3 standard deviations to the right. On the left end, it's going to be 1.9, 1.4, and 0.9. That's 3 standard deviations to the left. They want to know what's the probability that a person will use their computer less than 2 years. This is 2.4 years, and 2 years is probably around right here. That's a z-score of 2 years. Well, actually, z-score isn't really 2 years. The data points at 2. We need to know the z-score there. So the z-score is going to be the number they gave you, take away the mean, over the standard deviation. So it's going to be 2, take away 2.4, over the standard deviation of 0.5. So that's true. 2 take away 2.4 divided by 0.5 is negative 0.08. So this z-score is negative 0.8. So this is at the z equals a negative 0.8. So you want to go to the z-score table and figure out what's the z-score at negative 0.80. So here's the negative side. Here's negative 0.8. It's negative 0.80. So that's 0.211866. So it's this shaded region right here. So I have an area 0.21186, or 21.186% chance of someone using their computer for less than 2 years and they upgrading. So that's the answer for it. So the answer would be there's a 21.18% chance of a person using their computer for less than 2 years. That'd be the answer for that one. All right, let's try a new one. The next one says, cholesterol levels of American men are normally distributed with a mean of 215 and a standard deviation of 25. If you randomly select the American man, what is the probability that his cholesterol level is less than 175? Let's first create the normal curve. The mean is 215. Standard deviation of 25. So next number up is 240. Next number up is 265. And then 3 standard deviation is 290. Then go on the back end. 215 take away 25 is, it says 190. And then take away 25 should be 165. Take away 25 again, should be 140. So that's 3 standard deviations on each side. So we created the bell curve. Always do this first. And then after you do that, it says that the person's Z-score is 175. So it doesn't fall on one of these numbers. I'm sorry, the person's cholesterol is less than 175. So it doesn't fall on one of these numbers. It's probably around here. So these are people whose cholesterol levels are less than 75. So I need a Z-score for that number. So the Z-score for that number would be X take away the mean over the standard deviation. So it should be, the number they gave us is 175. Take away the mean, which was 215, divided by the standard deviation of 25. So 175 take away 225. I'm sorry, 215. Divided by 25. That Z-score is negative 1.6. So because the Z-score is negative 1.6, I want to find the Z-score from negative 1.6, area under the curve, negative 1.6. I'm going to find the area underneath the curve there. It's negative. Make it look better. Z equals negative 1.16. So go back to the table to the negative side. And negative 1.1 is here. 0.6 is here. So that Z-score is 0.12302. So that area is 0.12302. So the probability of that happening, you randomly selected somebody and their cholesterol level is that low, that's about a 12.302% chance of selecting someone with their cholesterol level that low. So I'm writing the sentences because in statistics, our job is to communicate the data. Like if you're comparing this to a doctor, he wants to know. He wouldn't really want to hear you say 12.32. He wants to hear you explain what that means. So it means it's a 12.302% chance of selecting someone with that cholesterol level. All right, hope that makes sense. All right, I'm gonna stop the video right there. I'm gonna get every other example. We'll make short videos, like 5 to 8 minute long videos, opposed to doing one that's 20 minutes long or 30 minutes long. So I'm stopping the video. That's all I have. Good luck.